In the closed interval, how we can find the absolute minimum and absolute maximum is already discussed. But in the open interval, it is a bit more difficult question. But to decide the either local minimum or local maximum is a bit easier than to decide the absolute minimum and absolute maximum. We use the second derivative test to decide the local extremum points. So second derivative can be used to classify the local extremum of a function. So how we classify? Actually, the idea behind the concavity, if function is concave up on the some interval, okay, let's show that here. This is local minimum as you see. So the graph is concave up. So always second derivative is positive. Yes, concave up like x squared, so positive. F prime is increasing, you can consider. So if f double prime is positive, your point at the point C, this is the point C, okay, if at the point C, so this is local minimum, okay. If we have like this situation at the point C, this is local maximum. Here f double prime at the point C is less than 0, okay. So second derivative test says this fact. We have a result table in your textbook. Okay, let's show that this table. Let's see the critical point. So what does it mean? F prime at the point C is 0. Critical point. So if f double prime at the point C is positive, so function is concave up, graph is concave up actually, local minimum. So f of C local minimum, first case. F prime C equals 0, f double prime C is negative in second case. This is local maximum. If f prime is C is 0, but f prime double prime of C is also 0, so in this case the test does not apply, okay. The test cannot be used. The test, second derivative test, does not apply, okay. So this test is known second derivative test. So this can be used for local minimum or local maximum, but also we can generalize second derivative test for the absolute minimum and absolute maximum. Let's give that theorem. So let f be continuous on the interval I. If I is closed, we can easily find, okay. So in general I is not closed, okay. Here sometimes in general it is open or half open. From A to B with only one critical number C in the open interval AB. So we can say that f prime is the absolute minimum, okay. So if f prime C equals 0 and f double prime C bigger than 0, then f of C is the absolute minimum. So what is the graph? Actually on the open interval I, function has only one critical point, so the graph like this one. So this point is C, so this is local minimum. If f prime C equals 0, this critical point, and f double prime C less than 0, then f of C is the absolute, okay, let's write here, maximum. So how the graph on the open interval I, function graph like this one, okay. So this point is the absolute maximum value, maximum point. Of course, we have some other strategies for the open intervals, but it is a bit advanced for you. So up to that point is enough for the business and economy student.